The next step in solving systems of ODEs is to move to non-homogeneous, and that is something in the form of x prime equals ax plus a vector f of t, so that vector will only be in terms of the independent variable t. And we're going to solve this with undetermined coefficients. Just like before, we first find our homogeneous solution, then we guess our particular solution, checking for independence, and then we put together our final solution as a homogeneous solution plus the particular solution. But I am going to say something. On exams, you don't have to check for independence. I promise you they will be independent. Not saying that for homework, but for the exam, you can skip that step because I will make sure that they are already independent. And I'm going to emphasize that if you have initial conditions, you need to find that C1 and C2 after you find the XP and combine it with a homogeneous solution to give you the final X. Alright, let's do an example. So, let's first find our homogeneous solution. That is, ignore the -11, -5. Hopefully at this point we're getting pretty comfortable with this, and it factors like so. So this means we have two real eigenvalues, R2 and R7. So let's go ahead and find the corresponding eigenvectors for each of these. And going through what we've done several times already, we'd find the eigenvector associated with the eigenvalue 2 is -1, 4, and an eigenvector associated with the eigenvalue 7 is 1, 1. Let's go ahead and combine those into our homogeneous solution. So now let's look at our particular solution. Our particular solution just looks like constants. So what my XP guess is going to be is simply two constants. This is in fact independent from the homogeneous solution. So let's go ahead and find the first derivative of this. Well, that one's easy. The derivative of constants is simply 0. So this is our original differential equation. Let's go ahead and plug in our XP and XP prime. And now let's solve for A and B. So following simple matrix multiplication, we get this, and with a little bit of elimination, I'll multiply the first equation by -3, and I find that A is equal to 2. And if I go ahead and calculate B, I'll find that B is equal to -1. And this is our final solution. Again, we use undetermined coefficients. We first found the homogeneous solution, then we guessed a particular solution, we checked that it was independent, and then we went ahead and solved for those undetermined coefficients and got our values for A and B.